Hello viewers, welcome once again to mathematics class. We shall continue with our laws of logarithm. In the previous videos, I've discussed 4 of the laws of logarithm, and in this one, I'm going to talk about the remaining 4. Now, the 5th law of logarithm is called logarithm to its own base. That is, if you have a logarithm of a particular number, let's say a, having a base a. Now, if the number and the base are the same, then the logarithm is 1. For example, e.g.1, if you have log 10 base 10, the answer is 1. Once the number and its base are the same, then the logarithm is 1. Example 2, if you have log 3 having base 3, then it is 1. It's just as easy as that. The 6th one, we are looking at the logarithm of 1. Logarithm of 1. That is, if you have a logarithm of 1 to any base, log of 1 to any base is equals to 0. For example, if I have log of 1 having base a, then it is equals to 0. If I take example 1, e.g. 1, next I'm having log of 1 having a base 2. Now, remember the way we used to solve it normally? We will say log 1 equals to, assume it is x. Then this 1 and x will exchange their position. Then you have 2x equals to 1. Now, in our laws of indices that I've spoken about, I've discussed about, anything raised to power 0 is 1. So from here, I can say I have 2x equals to 2 raised to power 0. I've changed my 1 to 2 raised to power 0 because anything raised to power 0 will give me 1. So 2 cancel 2, my x equals to 0, which means that anytime you have a logarithm of 1 to any base is equals to 0. As simple as that. Then the other one, number 7, is reciprocal law. Reciprocal law. Now, reciprocal law, as we have a logarithm, let's say log a b, log of b having a base a. If you want to find the reciprocal means 1 over, then something will happen here. These two will interchange. It becomes log b a. That is reciprocal law. Once you are finding the reciprocal of any logarithm, then the number and its base has to change. For example, e.g., if I have log 4 8 and I want to find the reciprocal of this log, then it becomes 1 over log 8 4. The 4 and 8 has changed their position. Then I can solve this one further. I can now say log 8 4 equals to x. In mathematics, we cannot do without x and y. These are two letters that we usually use most often. Now, log 8 4 equals to x. Normally, this and this will change and remove the log. So it becomes 8x equals to 4. Now, you solve for that. This 8x can be resolved to 2 raised to power 3 because 2 raised to power 3 will give me 8. Then my bracket x equals to 4 can be 2 raised to power of 2. Now, they're having the same base. I can cancel 2 and 2. So I'm having 3. 3 times x will give me 3x equals to 2. Then, to get my x, I will divide both sides by the coefficient of x, which is 3. Divide both sides by 3. Divide both sides by 3. So I have 3 cancel 3. My x will be 2 over 3. Now, if I come here, I can now input equals to 1 over 2 over 3. Then, from here, it will now be 1. My 2 over 3 becomes divided by 2 over 3. Now, from here, I can have, it becomes 1 times, this goes up, this comes down, 3 over 2. So my final answer is 1 times 3, 3 over 2. And then this one being an improper fraction can be resolved further to be 2 whole number 1 over 2. Just as easy as that. That is the 7th law. Now I go to the last one, which is the 8th law of logarithm, and that is change of base. Change of base. Change of base. What is that talking about? For example, if I have log, let's say log 2 and log 4. Log of base 2, log of 4 having base 2. Now, if I want to bring in another base, I want to change this base of 2. I want to change the base of 2. Then, maybe I want to change the base of 2 to 3. I have to make the base to be 3. Then it becomes log 3, 4 over log 3, 2. As simple as that. Now, look at it. I've changed the base to base 3. Then the first one carry 4, this number here, while the second one carry this 2 here. Look at an example, e.g. if I have log 4, 8. Now, I want to change this to base 2. This 4 now, I want to make it to become base 2. Now becomes log 2, 8 all over log 2, 4. Then these two, you can solve it further. Log 2, 8. Log 2, 8 equals to x. Then these two interchange becomes 2x equals to 8. Then 2x equals to what? 2x power 3. 2 cancel 2, your x equals to 3. Now, for 4, it becomes log 2, 4. Then equals to, let's say, y. Then 2y equals to 4. Then I have my 2y equals to 2 over 2. Cancel, cancel. Now y equals to 2. Now if I bring it here, it becomes, this one is 3. Y log 2, 4 is 2. I have 3 over 2. If I solve for that, it becomes 2 whole number 1 over 2. So these are the remaining laws of logarithm. So once you understand this law, then you can solve questions that you want to solve as regarding laws of logarithm or logarithm question. So in the next video, I'm going to take an example and I'm going to solve them using all these laws that we have discussed about. Thank you.